Hello everyone. Well, today I'll be having a new topic to discuss, the probability distribution. But before that, let me introduce myself first. I am Jeah Mae ang Talaub, yung mahal na mahal niya, Charis.
Probability distribution. Probability distribution is a statistical function that describes the likelihood of a variable taking each value that it can possibly take. It is a common way to describe and possibly predict the probability of an event. The sum of the probabilities in a probability distribution is equal 1, just because if the sum of probabilities is not equal to 1, then it is impossible to measure its probability of occurrence. So now, let's take an example of the probability distribution. We can use table for example. The following probability distribution tells us the probability that a certain soccer team scores a certain number of goals in a given game.
As what we can see on the table, the goals is 0 to 4.
And the probability of X is 0.18, 0.34, 0.35, 0.11, and 0.02. So, we have to confirm first if this probability distribution is valid. So, we have to plus or add this probability. 0.18 plus 0.34 plus 0.35 plus 0.11 plus 0.02 is equal to 1. So, the conclusion is that the distribution or the probability distribution is valid. There are specific techniques that can be used to quantify the probability for multiple random variables such as the joint, marginal, and conditional. With these techniques is definitely provide the basis for a probabilistic understanding of fitting a predictive model to data. Let me introduce first joint probability distribution. A joint probability distribution shows a probability distribution for two or more random variables. Instead of events being labeled A and B, the norm is to use X and Y. The formal definition is f of X and Y equals probability X equals X, Y equals Y. The reason why we use joint distribution is to look for a relationship between two variables. I have here an example table for the joint probability distribution. During a few wintry months in Boulder, Jim collects the following data, where he observed whether or not there is snow overnight and whether or not the bus is delayed. As a result, we have a total of 60 observations here. Upon the questions, what is the probability that the bus is delayed and there is snow overnight? So we have to look at the table and then the answer would be 5 over 60. And the second question, what is the probability that the bus is not delayed and there is not snow overnight? The answer is 36 over 60. So, we can take of our observations and divide it by the sum of all observations, which is 60. To get something known as the joint probability distribution. So, we do notice as the joint probability distribution for two random variables, this is known as the bivariate distribution. We refer that it is as f subscript x and y or x and y. And for the discrete variables, this is known as the joint probability mass function.
Next is marginal probability distribution. If x and y are discrete random variables and f(x) and y is a value of the joint probability distribution at x and y, the functions given by g(x) equals summation of y of x and y and hy equals summation of x, f(x) and y are the marginal distribution of x and y. If you are great with equations, that's probably all you need to know. It tells you how to find a marginal distribution. But if the formula gives you a headache, you can use a frequency distribution table to find marginal distribution. I have here an example. A marginal gets its name because it appears in the margin of a probability distribution. You can just look at any old frequency distribution table and say that the last column or row is a marginal distribution.
Conditional probability distribution. A conditional probability distribution is a probability distribution for a subpopulation. That is, a conditional probability distribution describes the probability that a randomly selected person from a subpopulation has the one characteristics of interest. Let's take an example with the use of table. The following two-way table shows the result of a survey that asked 100 people which sports they liked best: baseball, basketball, or football. If we want to know the probability that a person prefers a certain sport given that they are male, then this is conditional distribution. To find the conditional distribution of sports kung saan gusto ng mga lalaki, we must look at the values in the row for male were in the table. So look at the table first before to get the values of them. To calculate with a probability distribution, it is important to look at the subpopulation and the character of interest. The subpopulation is in the rows and then the characteristics of interest is the column. For male, we have to calculate first who prefer baseball. So in the table, there is 13 and we have to divide it into its total, which is 48. So 13 divided by 48 is equal to 0.2708. In basketball, we have the same process in baseball and how we calculate this. So in basketball, we have 15 divided by 48 is equal to 0.3125. In football is equal to 20 divided by 48 is equal to 0.4167. Notice that the sum of the probabilities adds up to 1. So we have to add this one first. 13 divided by 48 plus 15 divided by 48 plus 20 divided by 48 is equal to 48 divided by 48. 48 divided by 48 is equal to 1. So the probability is adds up to 1.
Joint, marginal, and conditional is easy to find, especially when we use table as an example. I firmly believe that each of them is calculated by events. I have here an example table which are the three techniques are in. Subjects in a sample are asked if they smoke. Results are further broken down by gender. The joint probability distribution table, marginal probability distribution table, and the conditional probability distribution table. And these are the overall results. The importance of probability distribution in relation to real-world phenomena, it helps to model our world, enabling us to obtain estimates of the probability variability of occurrence.